I'm going to throw everything at you at this question. I'm going to throw everything you could probably think of at this question. Let's see how you handle it. Woof! Okay, remember, this is a log-based 3 question originally. So it means that your graph is going to look something like that originally. Now you're going to do all the transformations to it. Well, A, B, H, and K, baby. That's the way to do it. Your A then is -2. Your B here looks like it's a -1 for right now. But again, ha. Did you see it? Did you see it? You didn't factor again. So you got to take the negative out, and this gives you x minus 1. Watch out for that factorization. Otherwise, this is going to mess everything up. Doesn't change the b, but boy, does it ever change the h. The h is now 1. The k, there's nothing out here. There's nothing out here, so the k is 0. Oh, well, gee, we're going to have fun with this one then. Okay? So horizontally, what happened? We obviously don't have a stretch, but we do have a reflection. So we're going to reflect. And how do we reflect horizontally? Yes, over the y-axis, and we're going to move 1 right. Whew! Next one. What's going to happen vertically? Look at this. We're also going to stretch, so we're going to do a vertical stretch of 2. We're going to reflect. Oh my goodness, reflect over y or x-axis this time. Oh, over the x-axis, and that's it. Okay, so let's figure out our mapping. That's the best way to do things. Mapping. Okay, so our mapping, x, y, becomes, all right, horizontally. Right? Reflect over the axis. 1 to the right. So this is minus x plus 1. Woo! Vertically, there's the minus 2. Minus 2y plus nothing. There we go. That's it. There's your mapping. So let's take this transform point now and let's start figuring things out. Okay, x. Put a 1 here. Look at that. 1 plus -1 plus 1. Huh, guess what it becomes? In fact, it does become 0. Oh, that's neat. And your y value, put it in here. What? You're going through the origin. Yeah, I'm just going to go through the origin right there. Isn't that interesting? Okay, now let's start looking at domains and ranges, and let's look at our asymptotes. Remember our asymptote. Our asymptote originally was the wonderful y-axis, which means x equals to 0. But now think about it. What are you doing? Well, x equals to 0 means this is a 0. Minus a 0 is 0 plus 1. Guess what? Your horizontal, or I should say your vertical asymptote is moved 1 unit right there. Look at that. Oh, this is so cool. Now, let's start thinking about a couple other things here before we start doing things here. Let's talk about the domain. Well, even before the domain happens, and even before the range happens, I'll give you a hint of the range. Yeah, I think you can figure out the range. Yeah, there you go. That's pretty easy. Okay, our equation of our asymptote, let's put that in while we're here. Okay, but I'm still concerned about the domain. Think about what you're doing here. First off, you've got 2 reflections. Oh my. So you're reflecting over the x-axis. So you're going to reflect over the x, and then you're going to reflect over the y. Oh my, what does that become? Okay, first off, let's take a look at our basic equation. If we reflect over the y, it becomes looking like that. If we reflect now over the x, it's going to look like that. Aha, so guess what? I just about pretty near solved the darn thing. This guy's going to come straight down here like this. It's going to boogie down here, and then it's going to start bending over this way. I know it's going to start bending over this way. I can figure that out. Think about it. It just makes sense, right? Based on the fact that you did this little ditty over here. Okay, so think about your domain now. Because you reflected it, your domain is actually on this side of the asymptote now. So you have to go, okay, the asymptote is 1, all right, but now you got to go less than 1. Ah, our x-intercept and y-intercept, you determined it just by transforming the point. The x-intercept is 0. The y-intercept is 0. No major math happening here. You don't have to do anything. What a cool question. If you know what you're talking about, these transformations actually become pretty easy.